Hello, my name is Adrian Cox-Settles, and I will be going over literal equations today. Now, I have been tutoring and teaching math for over 20 years, and literal equation is definitely a subject that students struggle with, especially when they're studying for the SAT prep. When they're studying for SAT and doing the SAT prep, the literal equations is something that it just blacks them out. Okay. So basically, literal equations when you mainly have letters, majority of the time you see a lot of letters, and sometimes you don't see any numbers at all. And so when students see this, they get like a blockage because they used to manipulating numbers around. Now they're really doing algebra when they manipulate the letters around. So I'm going to show you it's just as easy. You just have to remember what the rules are. If you know the rules, no matter if it's a variable, which is the letter, or if it's a star, if it's a shoe, no matter what, if you know the rules to algebra, you should be able to manipulate it in any way possible, any form possible. So let's get started. Okay, so I have a couple of equations here. I think I have like 15 or 16. So I am very detail oriented, but I'm gonna still try to be fast at the same time. So we'll see. All right, now solve for x. So solve for x means we're trying to isolate the x. We're trying to get x by itself. Now, we have x plus 3 equals 6. So what I want to do is I want to give you the basic type of equation. This is a linear equation, one step. And I want you to do these steps like you would normally do it. And then we're going to transfer that concept over to the literal equations because it's the same. So I'm going to try to build you up so you can see it. And then we're going to transfer that information so you can see it's the same thing. So we can just get rid of those chains, blockage, and whatever is stopping you from moving ahead. Okay, so let's get started. Let me go ahead and get me a writing utensil. Okay, so we have x plus 3 equals 6. Now, when you have algebra equation, you always do the inverse operation, the opposite operation. We're trying to get x by itself. So what I want you to do is isolate the x. I'm going to draw a little circle around the x. Now, that's something you don't want to touch until the very end. I'm circling the x because I don't want to touch it until the end. Don't move the x, leave the x alone, okay? Don't touch it. All right, now, since it says plus 3, the opposite of addition is subtraction. So we subtract 3 from both sides, okay? So this is a form of translation, okay? Or transformation when we're trying to go from one side to the other. Okay, now, my positive 3 and a negative 3, what happens? They cancel out. So you bring down your x, you can bring it down, equals 3. Now, once we have x by itself, the answer is complete. So x is equal to 3. And of course, everyone like, oh man, that's easy. I know how to do that. Okay, so if you know how to do that, let's do this. So let's come over here and look at look at this wonderful literal equation. Okay, x plus a equals b. Now, some students get to this and they like, what in the world is this? Where are the numbers? And so from there, they just forget everything that they learned. But we're going to do it again. First thing I want you to do is circle the x because we isolating the x. Instead of having a plus 3, we have a plus a. So guess what? We're going to subtract a from both sides. Yes. Okay, so the two a's cancel out. You drop your x is equal to what? B minus a. Okay, so B and A are not like terms, so you can't put them together to get one thing. Is B minus A, like apples and oranges, okay? They're two different terms, so you can show them being together by using a form of addition or subtraction, like a operation. Okay, so this is complete. The answer can be B minus A. Okay, now let me erase this. So please take a snapshot or whatever you have to do because I'm about to move the screen down. Well, the paper up. Okay, so clear all. Okay, now what I want to do is make it a little bit smaller. Let me get rid of this. Yeah, I'm doing some behind the scenes stuff that y'all can't see. Yeah, I'm working it out, working it out. Okay. Okay. Now what I want to do is do the check. You know, people like, okay, I got the answer. It really doesn't make sense. How do you check it? Okay, so let's do this. We're going to check with the first one. Okay. So the first one we said it was x equals 3. And this one we said it was x equals b minus a. So let me keep that there so I know what to use. All right, now, so x equals 3. So anywhere you see x, you plug in 3. Okay, so I'm just plug the 3 in here. So 3 plus 3 equals 6. 3 plus 3 equals 6. Now 6 is equal to 6, so we know it checks out. Okay, so if you want to check it all the way through, you have it going down where you see a twin, one on each side. Okay, now you could have stopped at 3 plus 3 equals 6 and put a check, but some teachers want you to go to the last step. You know, you might get an extra point by showing that one twin is equal to the other twin. Okay, now if you want to check on this side, so x equals b minus a, what I'm going to do is put this in parentheses since there's two terms. Okay, so everywhere I see x, what I'm going to put? B minus a. So we're here, I'm going to put b minus a. Now you can put in parentheses or you can just leave it right here. So I'm going to keep it separate since we have a plus sign. That'll save one step, equals b. Okay, now you're looking at this saying, oh my goodness, that's too much. Okay, so let's come over here. B minus A plus A. So what can we do? The two A's can cancel out because they have opposite signs. Bam, that's gone. So what do we have? We have B equals B. Now, is that true? Is that a true statement? Yes, it is. So the check is correct. That means your answer is correct. B minus A is equal to X. Okay, so just try to look at it. We manipulating the equations. Instead of using numbers, we using letters, but you use the letters in the same way you would use numbers. You just sometimes have to get out your comfort zone. And this is to test you to see if you really understand the concept. Not the concept if you only see numbers, but the concept, whether you see a sunshine, stars, shoes, whatever, you can still do it because you know what the rules are. Okay, so this takes your game to a higher level. Okay, so I'm about to go ahead and erase this, clear, and I'm going to move it up some. Okay, so let's go to the next one. So what I'm going to do is let me make it big. And okay, I'll keep it right here. Okay, so for this one, let me see. Would it let me do that? Okay, if I do it big, I'm not going to be able to write on it like I would like. Oop, they erased it from me. So let me pull it up again. Okay. I'm sorry about that. Some technical difficulties, but we're going to work it through. Your screen is paused. Okay, I don't want it to be paused. Okay, I wanted to share. Okay, so hopefully you can see that and you're not just looking at me. All right, now what I want to do is you can see my screen, but it's not allowing me to write. So let me do what I'm doing. All right, and come on. Oh, I got to press escape. Get out of here. Okay, now let me go ahead and finish up. I'm sorry about that. All right, let me go and do my thing. Let me do what I do. All right, now we're going down to the bottom. X minus 4 equals 6. So the opposite of subtraction is addition. So we're going to add 4 to both sides. Okay, cancel out the 2 4s. Transposing, that's the word I was thinking about. We are transposing when we have one on one side and one on the other side. I think I might say translation or transformation. And they can also be seen that way too. All right, so you get x equals 10. Okay, so we do the same thing. You come over here. And then you have, you're trying to get the x by itself. You can isolate the x. You can add t to both sides. Okay. Add t to both sides. The t's cancel out. You get x equals W plus T. And that's the answer. X equals W plus T. It looks kind of crazy, but that is the answer. Now, over here, X equals 10. You take that, you plug in 10 where the X is. So 10 minus 4 equals 6. 6 is equal to 6. And bam, there you have it. Now, let me move this. Have these extra things over here. Why is this still saying this? Okay. All right, so over here, so let me just look at this. Same thing. If you have subtraction, you want to change it to addition. So add, oh, sorry. Yeah. So right here, let me go ahead because I am, let me see. I'm sorry. It's something that's blocking on my screen and it just won't go away. Yes. It's just something blocking things from happening. So let me see. All right, let me do it like that. I don't know why it's blocking it right there, but I'm not even going to worry about that. So what's next is you have right here we're doing the check. So we're not solving. So let me do that first. So you have x equals w plus t. So that's plug in w plus t. Everywhere you see x. So you do w plus t. Now you can keep it in parentheses, but if it's addition or subtraction, subtraction might be sometimes tricky. However, I'm going to keep x, this is in front. I don't have to put it in parentheses. X, okay, x, w plus t. Let me make it look neater. I'm sorry. It's a little hot in here. I'm getting a little hot. Okay. W plus t minus t. See, this part is a w plus t. Minus t equals w. So you have the two t's, they cancel out because they're unlike signs. And so you get w equals w. So this is how you know that x is equal to w plus t. Okay. So this is just another way we go through, we check, and so on and so forth. So let me clear this out and go to the next one. Okay. Like I said, I have something just keep covering what I'm doing, and I don't know why it's doing it. So let's go to the next one. Okay, we have that. Okay, I had it set up where it's supposed to come on. Okay. And here we go. All righty. Okay, we did that one. So, new share. Let me see. Right here. Okay. All right, we getting back in business now. All righty. Yes. Here we go. Now, for this one, we're going to solve for x. So I have 4 plus x equals 10. So this is pretty much around the same. You know, I just switch the 4 in the variable, which is x. You know, because sometimes when you switch it, some students get off track, like, oh my goodness, I'm used to the x being first. But in algebra, you have to be prepared no matter what, how they give you the equation to use what you know already to go through and complete the equation. All right, so you have you have 4 plus x equals 10. So you want to isolate the x. Okay, look at the sign in front of the 4. If you don't see a sign, it's supposed to be a plus 4. So put a plus there. Now, how do I get the 4 away from the x? I'm going to subtract 4 from both sides. Go through and subtract it. These 4's cancel out, and I get x equals 10 minus 4 is, right, 6. Now you go over here. We want to transfer this concept over here. Okay, so we're trying to get x by itself. What is messing with the x? Okay, the w. Is the w positive or negative? It's a plus or it's positive. So what you want to do is to do subtraction. Subtract the w from both sides. Always try to do the opposite. The w's cancel out. You get x equals k minus w. Okay? Now, if you wanted to put the w first, you would just have to write negative w plus k. It still would be the same. I'm just going in order vertically. Okay, now right here, if you want to check it really quick, you put the 6 where the x is, and you say 4 plus 6 equals 10. 10 equals 10. Yes, it's correct. Now, if you want to check this one, K minus W, you put it where the X is. So you can say W plus K minus W equals K. Now, if you wanted to put it in parentheses, you can. Okay, it's always safer to put in parentheses, and then you just write an extra step if you don't mind writing an extra step. So it would be W plus. So basically, there's an imaginary one in front of the parentheses. So that's how we get everything out. We multiply everything by that one, which is the distributive property. That's what you're really doing. So you're not just dropping it, you're multiplying it by a one to take it out. Okay, so that'll be K minus W equals K. And then the K, and what happens here? The two W's cancel out because one is negative, one is positive. So you get K equals K. Now, if both sides are equal, well, if both sides are equal, that means that your answer is correct. So we know that this is correct and that's correct. Okay. Now, I'm going to erase this. Clear. Make this smaller. Let me get out of here. Like I said, I have some blackage on the screen. I don't know what this is for, but I'm going to work through it. It's good that you all can't see it. Okay, so next I'm going to, maybe I use a different color. I've been using black. Let's use something a little bit lighter. Let's use red, burgundy. Okay, so you have 7x equals 21. Okay, 7x equals 21. So anytime you have a coefficient connected to a variable, the coefficient is the number that's in front. That's multiplication. And anytime they connect it with nothing in the middle, that's multiplication. So it's 7 times x equals 21. 7x equals 21. Okay, so the opposite of multiplication is what? That's right, division. So we can divide both sides by 7. Okay. We draw the little division bar that shows division. Now, if you want to do the other way with the line and the dots, you can do that also. Okay, so you divide, the two sevens cancel out. You get x equals 3. Okay, good. We're going to do that same concept over here. We're looking for x. So what you want to do is, you can, if you want to, you can isolate the x by circling in the x. And you can say, okay, bx means b times x. So in order to get rid of it, I have to divide both sides by b. Divide by what's bothering the x, or what you're trying to get rid of. Cancel the b's out. So you get x equals c over b. Now, getting to this part, x equals c over b, some of this will blow people away. But if you follow the rules, whatever you get at the end, that's going to be the answer. Because I'm going to show you how to check it. So you have x equals 3, and what you do right here for the check, you plug the 3 in with the with x's. So since I said 7, x is 7 times x, you're going to do 7 times 3 equals 21. 7 times 3 is 21, and 21 is equal to 21, and the check is complete. Okay? Now you come over here. We said that x was equal to c divided by b. So wherever we see x, we have to put what? C divided by b. Okay, so I'm going to bring down my b, and why c x? I'm going to put c divided by b. Okay, equals, okay, let's go back to original question, equals c. Okay, all this was supposed to be equal to c. Let me make it a little bit neater. Let me make it a little bit neater. Okay, I need my utensil. Yep, I have blockage at the top. I don't know what's going on. Okay, so I have b times the quantity of c divided by b equals c. So what I'm going to do, you have the b in the numerator, b in the denominator. You can cross it out. Bam. So you get c equals c. So is c equal to c? And if it's a yes, bam, you got the answer correct. So x is equal to c divided by b. Okay, so remember, people get blocked and they just get like, I don't know what to do, and they totally shut down. Just remember what you have been taught and apply it to the literal equations. Okay, so let me clear this out and let's go to the next one. All righty, so let's see. Let's stop here. Should be this one. Okay, let me see. Okay, we did this one. All right, stop share. I'm trying to see. It's so small, and I'm trying to see it. It's so small. Okay, so might be that one. Let's see. Okay, this one. Okay, now, like I said, I got some blockage going on. I got blockage going on. Okay, so solve for X. Okay, so we're on number 9, solve for X. All right, so what we're about to do is, all right, so this right here is a two-step linear equation. Now, this is a two-step linear equation because I have two operations going on here. I have addition, ba, 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 and I have multiplication, ba, ba, ba. So that means to undo it, I have to do subtraction and division. You got to do the opposite, okay? So I already know by looking at this, since I have addition and multiplication, I'm going to do subtraction and division to get rid of it. Now, what order do I do that in? Now, when you're solving equations, you do the opposite of the order of operation. Okay, that's where people get stuck. So the order of operation, you know, please, excuse, my dear Aunt Sally. Okay, so when you are doing equations, you're going opposite. You're going opposite. So you're not going to start with the parentheses. You're going to start with addition or subtraction first. You do the opposite of the order of operation when you're trying to undo the equation. Okay, so we're trying to undo the equation to solve for a variable, but when mathematics, when you have like an equation and you have a lot of numbers, you're trying to break the equation down to figure out what that answer is. This one, we're trying to undo the equation to try to figure out what the X was or what it was originally. So we're going opposite. So you do addition or subtraction first. So we look at this right here, we have addition. So we're going to do subtraction. We're going to subtract 6 from both sides. Okay, cross that out. You get 3x equals 12. Okay, now you know 3x means 3 times x. So the opposite of multiplication is division. So we're going to divide both sides by 3, which is the coefficient. And you're going to cancel out. And you're going to get x equals 4. Okay, 12 divided by 3 is 4. Okay, and that's how you do that equation. Now you come over here and apply the same rules to this one. Ax plus c equals z. Now you have, I made z like this because the further and further you go up in math, you know, you don't want your z's to look like 2's. So in mathematics, we put a little line through the z so the teacher would know that's a z and not a 2. And that's a big deal. You don't want to get, instead of getting a 100, you get an 80 because you thought it was a z, but it looked like a 2 and so on and so forth, and you got the answer wrong, you know. So you want to make sure you distinguish what's the difference between that. Now, you're trying to get x by itself. So let me go ahead and isolate the x. Okay, so I don't want to touch the x. I do not want to touch the x. Okay, I'm gonna save that for later. Now, the next thing I'm going to do, since I'm doing backwards of the order of operation, I'm going to look for addition and subtraction first. So I see addition, so what I'm going to do, subtract the c. Okay, subtract the c. And then this cancels out. I get ax equals z minus c. Let me get a darker color. I'm sorry, because I don't want anybody. Oh my goodness. Okay, now you're still trying to get x by itself, but the x is connected to the a. So they multiplying each other. Anytime they're connected with no operations inside, it's multiplication. So since a times x, in order to get rid of the a, you have to divide everything by a. Okay, you go ahead and you can cross out the a. So x is equal to z minus c divided by a. Okay, so that's your answer. Now for the check, for this one right here, you get x equals 4. You plug in 4 wherever you see x. Remember, it's multiplication, so we want to use a ray dot or parenthesis. And we want to check and see if it's right. 3 times 4 is 12. 12 plus 6 equals 18. Okay, 18 is equal to 18. Therefore, the answer is correct. All right, we come over here. We get ax plus c equals z. Now with this one, we said that x is going to be z minus c divided by a. So let me make some room. So I'm going to rewrite everything over here. So I'm going to have a, oops, and in parentheses, I'm going to have z minus c over a equals z. Okay? Did I do it right? Oh, I forgot to put the C. Oh, I gotta put the C down. Oh, it's not gonna come out. I kind of caught that. I was like, wait a minute, it might not come out. Look all right. All right, now when you have something like this, you have A in the numerator. Then make it in the numerator. Guess what? I'm put it over 1 so you can know what I'm talking about. A in the numerator, A in the denominator. Basically, I can cross those out. Those cancel out. So in the parentheses, I'm gonna bring down Z minus C plus C is equal to Z. Okay, C, Z, Z, C. Oh my goodness. Now, I have the C's canceling each other out. And so what do I have? Z equals Z. So Z equals Z, I know that's correct. Okay, so that's how you do that. Now, let's look at the bottom. Let me keep it moving. Let's use green. Now I have 20 equals x times 2 plus 4. Anytime you have the symbol, that's called a radii, and it's multiplication in algebra. Okay, we don't use x's anymore because x is a variable. It stands for a number. So we don't use x's for times anymore, you know. So we took that out. We're in algebra now. So x actually represents a number, not a symbol in algebra. Excuse me. So I have 20 equals x times 2 plus 4. Now, I already told you that in order to solve for the variable, you have to do the opposite of the order of operation. So we come up here, we look again, you want to look for addition and subtraction first, okay? So you look up here and say, oh, I'm trying to get x by itself. Am I going to do the multiplication first or am I going to do addition first? Remember, you do the opposite of order of operation when you're solving for variables. You do the opposite of order of operations when you're solving for variables. So no, I'm not going to do multiplication first because multiplication will come first if it was doing something else. But when we're doing equations, solving for the answer, we're doing the opposite of the order of operation. So no, we're not going to multiply first. What we are going to do is we're going to do the addition, but we have to do the opposite, which is subtraction. So we're going to subtract 4 from both sides. Okay, we're doing the opposite of the order of operation. Opposite order of operation. Okay, so look, 2 4s cancel out. And you get 20 minus 4, which is 16, equals, you bring down the x, times 2. Okay, the opposite of multiplication, is division. So I'm dividing both sides by 2. And I'm going to come here, cancel out the 2. 16 divided by 2 was 8. So x is equal to 8. Okay, you could have had 8 equal to x. And then last step, switch it around because some math teachers are very particular. They want to see the variable on the left side. So most of them want to see on the left side. So give the teacher the answer on the left side. But in actuality, it's the same, but give the teacher what the teacher wants. Okay, so now we apply this concept over here. And we look over here, we're trying to get x by itself. Now, the operations that's being done to the x is multiplication, and then you see an addition, you know, on that side. So we know that we're not going to do multiplication first because when you're solving for the variable, you do the opposite of the order of operation. So I already know that I'm going to go ahead and do something with that addition. And what I'm going to do, I'm going to do subtraction. So I'm going to subtract the r from both sides. Okay, cancel that out. Bam. You get h minus r equals x times c. Okay, so the opposite of multiplication is division. So I'm dividing everything by c. Okay. Now, in class, you can put the C under the H and then the C under the R. You can do that. But since I'm going through and I'm taking time to check it, I'm gonna keep it like that because it's easier to check if the C is just the denominator for the H minus R. Instead of having it separate, it's like a little bit easier. Okay, but it really doesn't matter, but it's a little bit easier to look at. All right, now, so I'm going over here to check it. X equals 8. So I'm going to plug in 8 where I see the X. So 20 equals 8 times 2 plus 4. Okay. Now, I'm not solving for a variable at this point. At this point, I am doing order of operation because I just have odd numbers. Okay, since I have odd numbers, this is order of operation. Okay, so I'm gonna bring down my 20, leave that alone. Come over here, 8 times 2 is 16, plus 4 is 20. Okay, when you have odd numbers, do the order of operation. But when they throw the letters in there, do the opposite of the order of operation. If you're trying to solve for the variable, to get the variable by itself. Okay, only if you're trying to solve for the variable and there's an equal sign. Now, if you're not trying to solve for the variable and there's not an equal sign, that's an expression. And if you do have an expression, you can use the order of operation because you're not solving for the variable, you're just breaking the variable down to a simpler form with the numbers. Okay, so 20 equals 20. Let's check. Now, over here, we're gonna plug in. Okay, I didn't cancel out. Sorry. So X is equal to H minus R over C. And like I said, if you want to make it look nice for the teacher, put the variable on the left and the answer on the right. Okay. Yeah, we like that. We like it to look like that. Now, we're going to substitute X minus R over C everywhere we see X. So I'm going to put my H over here. Just I'm going to rewrite this. I'm moving because I need space. Where the X is, I'm going to put H minus R over C, right? Times C plus R, okay? All right, now we have this right here. Remember when I say you have a C across from a C, you can always cancel that out. Okay, that's automatic. Okay, so you have H equals H minus R plus R. Now the two R's cancel out, so you have H equals H, and that's correct. And that's how you do that one. Okay, so that should be good for you all. I'm gonna clear this out. And then I'm going to go to the next page. All right, I'm gonna see if it lets me go this way. If not, okay. If it doesn't let me go this way, I'm going to use this. Okay. Let's see. Do I have it? Is it coming? Okay, yes, coming. All righty, so here we go. And they said it's pause. Okay, so here we go. Is this the same one? Okay, I did this one. I just went to the next one and they just moved it. Okay, let me move it again. All right, where did I see it? Do I gotta go and get it again? Okay, here we go. All right, let's get to it. Number 13, we're gonna solve for M. Let me give you something different from X. Some people are like, I'm getting tired of X. I'm getting tired of X. Okay, so I'm gonna put an M on it. You want M. Okay, let's make this money. It's like, all right, so solve for M. All right, so solve for M means to isolate M. So what we're going to do is I'm going to go ahead and circle my M. And that's the last thing I want to touch. Okay? Keep away from the M. Keep away from the M. Okay? All right, now, for this type of problem right here, I put a few numbers in here. Still, you might see some numbers in literal equations. Now, we're trying to get the M by itself. This right here, the M is attached by multiplication. This right here, the M is attached by addition. When you solve for the variable, you do the opposite of order of operation. So you start with addition and subtraction and you go up, okay? So I'm going to do my addition first, but in order to do that, I have to do the opposite, which is subtraction. So I'm going to subtract 5D from both sides. Okay, subtract 5D from both sides. I cancel that out. And I get 5MD equals 10W minus 5D. Okay. Now, I'm still trying to get M by itself, so I'm going to leave the M alone. Now, what's attached to the M? 5 and D. What are they doing to M? They attached with no signs in between, so that's multiplication. So what do I want to do? Right, division. Now, you can do one at a time, but since the numbers are both attached, you can just go ahead and divide both of the numbers through at the same time. So you can cross out 5 and D. Whatever you do on one side, you do on the other side. 5 and D. Okay, so right here, you will have M equals 10W minus 5D over 5D. Okay. Now, some teachers will want you to break it down further. So I'm going to go ahead and break it down because I'll be one of those teachers. Like, now you had to simplify that, put that in the empirical form. All right, so let's do this. I'm going to bring it over here. And then I'm going to erase it so I can do the next one. But I said M equals 10W minus 5D over 5D. Now, when you're dividing 5 by everything, now what you can do, since you see 5 can go into the numerators, you can do it like this. M equals 10W over 5D minus 5D over 5D. You can take the denominator and put it under the first term, and then take the denominator and put it under the second term, so you can really break the numbers down all the way through. Okay, so right here, when you look at the first term, 10W divided by 5D, 5 can go into 10 two times, so that would be M equals 2W over D. Okay, minus 5D divided by 5D is not equal to 0, but is equal to 1. Okay, so the answer would be 2W divided by D minus 1 for the first answer, which is 13. And I'm going to have to erase it so I can get to 14. All righty, so I'm going to clear that out. And let's do 14. Now, 14, we're trying to look for M. So what I'm going to do is draw a little circle around M and know that I'm not going to touch M. I'm going to manipulate everything around M and move it to the other side of the equal sign. That's the game. And the way you manipulate it is that you do the inverse operation. But what you do first, you have to do the opposite of order of operation. And so once you know all of that, you're like, oh, it's good now. Okay, so we have multiplication here. And we have addition here. So remember, we're doing the opposite of order of operations. So we're not going to do multiplication first. We're going to mess with the addition. So what's the opposite of addition? Subtraction. Subtract 6Z from both sides. Okay. Now, 6Z's cancel out. You get WM equals to 12 minus 6Z. Okay, now, you're still trying to get M by itself. M is connected to W. Since there's no operation in between, they're attached. Is multiplication. The opposite of multiplication is division. You got it. So we're going to divide both sides by what? Yes, by W. Okay. So I cancel this out. And so M is just equal to 12 minus 6Z divided by W. Since W doesn't have anything in common with 12 and 6Z, but like factor of 1, it would give you the same thing. You keep it like that and you're pretty much easy. That's the simplest form. Now, if your teacher wanted you to factor the 12 and 6, take out the GCF and all that, then you would do that. You would factor out the 2. But so I'll put that over here just in case you have a teacher that would want you to do that. Some teachers would, if they're going over factoring too, they would say completely factor the equation. So let's factor the equation. Let's take that into account. Okay, so you have 12 minus 6Z over W. If your teacher wants you to factor out the GCF, which is greatest common factor, you try to figure out a factor that can go into 12 and 6, the biggest one. And the biggest one is 6. Okay, I don't know if I said 2 earlier, but the biggest one is 6. You take out M equals, you bring out your 6, you make your parentheses. 6 goes into 12 2 times, minus 6 goes into 6 1 time, and you put the Z, and you put it over W. Okay, so this is the simplest form as far as being factored. But if you distribute the 6 through, you get the same one on top. So it's really equivalent. But if your teacher says she wants it factor all the way through, you have to factor out the GCF and show her this, or him. Okay, him or her. Okay, so I'm finished with that. Let's go to the bottom. Sometimes you have these literal equations and you have fractions into it. Okay. So you have 1/6m plus KB equals W. We're solving for M. What I'm going to do is circle the M. Okay. I'm going to work around it. Right here, you can say, now when you see this 1/6, you can look at this 1/6 as being division, or you can look at it as being multiplication. It depends on how you want to see it. Okay. Now what I'm gonna do, I'm gonna look at it as being multiplication. Okay. So if I want to look at it as being multiplication, because like I said, it's a fraction, it's already a division, but it's attached, so it's considered to be multiplication also. So I'm gonna do it because I want to use the reciprocal. I got it. Okay. So I got 1/6m plus KB equals W. Okay, so what I want to do is, and we're not going to touch this first, so I don't even need to worry about this yet. Yeah, you're not going to touch this. Okay, so what I want to do, you have this attached. We're not going to mess with this, and you have addition. So what is going to happen, we're going to subtract KB from both sides, because that's the subtraction, addition, subtraction part. We get rid of that first. That's the added on part to give it two parts instead of one. So we want to make it one part with the M instead of having two parts. So, you can think of it like that too. I have the two parts in this equation. I want to move one part over. Now I was getting down to, one part by itself. So you have 1/6m equals W minus KB. Okay. Now you had the 1/6 with the M. Now, when you have a fraction, when you have the fraction with the variable, to get rid of it, what you can do is multiply by the reciprocal. Okay. Or, yeah, multiply by the reciprocal. The reciprocal of 6/1 is, 1/6, 6/1. 1/6 is 6/1, which is 6. Okay. But we're doing reciprocal, we're going to put the 1 there. Okay, whatever you do on one side, you do on the other side. So since this is two parts, I'm going to put that in parentheses and do it like that. Okay, because I want the 6/1 to be attached to the entire parentheses instead of being attached to one part. So the 6 cancels out, the 1 cancels out. You get M equals, and then you can leave the 6 on the back or put the 6 in the front. It's still the distributive property. So you have 6 times the quantity of W minus KB. And that's the answer for that one. Okay. And that's number 15. So I'm going to erase that and get to 16. Now 16, you got P equals 2 times B plus M. Okay. And we're trying to get M by itself right here. So we're not going to touch that. What we're going to do is we're doing the opposite of the order of operation. Put this down again so you can see it, because people get real confused with this. And I put the M and the D beside each other, because remember, whatever comes first from left to right, you do. So if the D came first, you did that. Whatever comes left to right, you do addition or subtraction. That's why I put them on the same level. They are equivalent. You don't do multiplication before division all the time. If division is first, and when you put your finger as you read through it, and you hit division first, you're supposed to do division first. Okay, that's why I put them beside each other. All right, now, so it says addition, subtraction. So since it's in the parentheses, we can't touch that yet. And then we have multiplication, division. Okay, we got parentheses last. So we do parentheses last. So what I'm going to do is take this 2 and divide both sides by 2, because they said do multiplication first. Okay, so my multiplication becomes a division because I'm solving an equation, looking for a variable. And so I'm going to get B plus M. Once I take the 2 away, I can drop down to B plus M, because remember that 2/2 canceled out and got a 1. The 1 was distributed through, which dropped it in. So that was a step that happened. The 1 was distributed through the parentheses. So I have P/2 equals B plus M. And I'm trying to get M by itself. And the only thing attached to the M is the B. And the B is positive. So I'm just going to subtract B from both sides. Oops, I'm about to make it a 6. Subtract B. Let me do this. I'm sorry. I was notified I have to do something in a few minutes. So I'm going to still leave here nice and neat as possible. Okay, so my 2 B's cancel out. And so I get M equals P over 2 minus B, or if I flip it around, it's going to be M equals P over 2 minus B. Okay. So you have it. Okay. These were some equations that I came up with. I said, let me just go through and do this because I knew my time was going to be somewhat limited and I wanted to have some fun. I wanted to take you through everything. I wanted to inform you that it's just like having the basic equation that's using the same mindset and doing the same rules and using the same rules to apply it. And if you have a complex moving letters, you can plug a number in so that you'll feel comfortable moving it around. Like for instance, if you had something like x plus k equals t. Okay, x plus k equals, let me make it a little neater. Okay, x plus k equals b. Okay, so if you had this and you get a blockage and you don't know what to do, and you solve it for x, you can come over here and just say x plus 3 equals b, or x plus 3 equals 9. You can change those two other letters around just for a second so that you can know what to move. And so in this part, you'll say, oh my goodness, I know to get rid of the 3. So instead of getting rid of the 3, you got to plug the k back. So that means you will subtract k from both sides. And then you take the 9 and change it back to a b. So you have to do what you can do so that you can be able to get your mind together in order to move certain things around. So like I said, you'll go back and you'll plug everything in, but you can plug a number in here and there so you can know what is needed so that you can go through and do that particular problem. Okay, when I show students just plug a number in, they knew right away what to do. But you have to be able to put the numbers back. Just putting the number there kind of pushes your thinking forward and gets you, on the right path because you've been like kind of trained to see numbers. But with practice, you're going to be seeing that the numbers and the letters are pretty much being used the same way. It's just that you get a complex because you don't have any numbers to feel safe with. You have these letters there. You're like, what in the world? It's a whole different universe. But yeah, that's it. Hopefully I made things easy for you. It was fun. And I had to go before I get reminded again. So peace. I plan to make another math video, maybe doing quadratic formula or something else that's fun. If you want to, you can give me comments of something you would like to see, and maybe I can do something like that. All right, thank you. Peace. Have a great day.